All right, full disclosure, this was recorded after finishing the part of the video you'll be watching after this, but I think I went a little too fast through it, so I'm just going to go ahead and give a little preamble over some of the hotkeys I used throughout the video. So I'm just in an empty scene here in Unity. I recommend using a mouse. If you use a scroll wheel, that's how you zoom in and out. Left click is how you select things. If you right or middle click, you can pan around the scene. If you go ahead, this is called your hierarchy. Basically, you can think of this as a folder view for the things that exist in the scene. This down here, this is your project view. This is essentially the same as your file view for the project. So if you were to go into your file explorer, you could see all of these as .asset files, .scene files, etc. At this inspector, this tells you about game objects you have selected. So game objects live over here in your hierarchy, whereas assets live down here in your assets, or in your project. The console tab, this is anything that goes wrong, or anything that you log to the terminal will be displayed here. Again, the inspector is for selected game objects. The only game object in an empty scene is your main camera. So if I go ahead and click on my camera, you can see it shows the different components, such as the camera component. I can go ahead and close and show some of these. The audio listener, which doesn't have anything to show. The universal additional camera data, again, nothing to show. And then transform, which has like its location and stuff. If you ever want to reset something to normal, you can right click, do reset. If you want to remove something, right click and click remove component. You cannot remove a transform. Every game object needs a location in which it lives. To go ahead and add a game object, you can right click in here or click this plus, and you have all of these to select from. So a 2D object, sprite, square gets you a square. You can see it kind of made it in a random spot, so I like to right click, reset, and that puts it back at the origin, which is the middle of our view. Again, scroll wheel to zoom in and out. If we go ahead and we select it with a W, it will look something like this, or it shows the axes. If you drag on the green, this is the y-axis, this will only allow me to move it up and down. Control Z to undo. If you grab something on the red, this is the x-axis, it'll only allow me to move it left and right. And if I click and drag on this little blue square, it'll allow me to move it wherever, free movement. If I go ahead and, so the hotkeys are QWERTY. So Q is to pan, but you can always access this just by right clicking. W is that tool. E is to rotate. So you can click on these. For the 2D project, we only really care about this blue one, which is this Z rotation, which you can see right there. R is rect, so this is how you stretch things. And then T is what I like to call the better rect tool. This allows you to move things and stretch things in a single direction rather than equally in both directions. This allows you to invert things. And then Y is the ungodly tool. It is pretty much all of them in once. So you can move it up, down, left, right. You can scale it. You can rotate it. It is, think of it as your Omni tool. I've never once used this legitimately. Okay. Stuff like this over here in the sprite render, because we will be working with a lot of sprites. The most important thing to look at is this order and layer. If we go ahead, Control C, Control V to create a new sprite, and I set its color to something like green, I can go ahead and put it at the same layer, but the order in which they are created is kind of arbitrary. So if I go ahead and I create another one and set it to red, the order in which they are rendered on top of each other is kind of arbitrary. You see, changing the order here doesn't really change the way they're rendered. But what I can do is I can click on this, and if I want this red one to be rendered on top of this green one, I can change its order and layer to be something larger, like 1, and now you can see it's on top. If I want this green to be rendered behind the white, white's on 0, so I could set this to something like -1. So that's pretty basic on what that does. There's a way to automatically sort objects based on location. We won't get to that in this video, but in the next video we will. with that, last thing we'll cover, this is what's called scene view. This allows you to interact with the objects you can see. This game view shows you what your camera is seeing. So if you click over here, you can see right now it's not seeing anything. So that would have to be something I would want to fix if I were to make this a proper game. That being said, let's get into the proper tutorial. Alright, let's get started. So the first thing you'll want to do is you'll want to create a new project. The editor you use isn't super important. I don't recommend Unity 6. It's been not super stable. I'll be using 2022.3.52. Go ahead, choose Universal 2D. Name your project whatever you want. I named mine Roguelike Tutorial. Put it wherever you want. And then I like to disconnect Unity Cloud and everything, and go ahead and hit Create Project. It will take anywhere between 2 and 10 minutes, depending on your hardware, for the project to be created. Once it is created, you should have something like this. So go ahead, pause the video until it opens up properly. Alright, the first thing we're going to do is we're going to take care of some bookkeeping. So as part of the Universal Rendering pipeline, creates this little global settings asset. I'm going to go ahead and drag that into my settings folder. I'm also going to create a couple of new folders, a player folder, we'll do tile maps folder, and a UI folder. If I'm going too quick at any point, feel free to slow down the video or pause it at any point. I'm also going to go ahead and change some settings in the camera. I'm going to set it from its size 5 to 8. And then in the game, I'm going to make sure it's 16:9 aspect, or 16:10 if you're working with a 16:10 monitor, rather than free aspect. If we go to scene, you should see something that looks like this. Now we're going to go ahead and create our player game object. So you right click over here in the hierarchy, you do create empty. I'm going to name this player, make sure it's set to the origin. 000, so you can right click, hit reset, and I'll go ahead and do that. I'm going to right click on the player itself, do 2D objects, sprites, square, and I'll name this sprite. This is going to be the child object of the player. You see how it's nested underneath. That will go ahead and contain the actual player sprite. For this video, it's just going to be a white little square for now, until we get the actual functionality working. Alright, go ahead, navigate to your player folder. This is your assets menu. This actually mirrors the same thing that you'd see in your folder directory, whether you're on Windows or Mac or whatnot. Right click in here, and we're going to create two different scripts. The first one we're going to call player stats. And then the second one we're going to get ahead, reloading domain, we're going to call player controller. It's important when you name these scripts, use something called Pascal case, which just means the first character of each word is capitalized and there are no spaces in them. Go ahead, open them up. Should open up in whatever you have as your default IDE. Mine is Visual Studio. Okay. Now we're going to do a couple things. First thing is, this isn't talked about a lot, but we're actually going to use something called namespaces, which basically just means the code we're writing exists in its own little world, and this will make Unity reload the domain faster, which is one of the big complaints with Unity. So little tip there. So we're just going to call this namespace roguelike, and then we want the subspace player. So this is where all of our player-related stuff in here will go, and we'll go ahead and delete everything in the script. So we have this empty mono behavior class. This little colon means this class that we're creating inherits from this class. Mono behavior is a Unity defined script that allows us to attach it to game objects. In player state, I'm going to do a similar thing where I add it to our roguelike.player. I'm going to delete the inside, and then I'm actually going to change, rather than inheriting from mono behavior, we're going to inherit from scriptable object. We're also going to create a little tag up here that says create asset menu, and then as an argument we're going to type in menu name, and we're going to set menu name equal to player/player stats. This will allow us to create one in the assets folder. I'll show you how that works in just a minute. While we're here, we're going to also add in a couple of attributes. I like to use private variables and serialized field to make them available in the inspector, so that way not any script has access to editing these. So it's going to be private variable. It's going to be a float, which just means a decimal number, and we're going to call this speed. We're going to do a similar thing with another value called health. Now what we're going to do is we're going to create this region and end region is just a way to organize code, but we're going to go ahead and put properties here. Properties are just ways to interact with variables, usually publicly. So we're going to create a public float and then capital S speed. We're going to do get return speed. This is C# syntax for what's called property. This just means anything can get access to the speed variable under the pseudonym capital S speed. If you wanted to create a setter, which we'll do later, you could do something like that. We're not going to. We're going to do the same thing with health. So public float health get return health. And that is going to wrap up this for now. We're going to jump back into player controller. We're going to do serialized field private. Now we actually need a reference to our player stats. So we're going to do player stats and then call this variable player stats. The serialized field means, again, it will be available in the inspector. We need to add a rigid body to our player object, so it can move around. A rigid body just allows for movement and physics and whatnot. So we're not going to serialize this. We're just going to do private rigid body, and then you need to do 2D because we're working with a 2D game. We're just going to call this RB. We're going to add an awake method. This just means when an object is instantiated, whatever is in these two little curly braces, that code's going to be ran. So we need reference to the RB. This variable can hold a rigid body, but we need it to hold this object's rigid body. So we do RB is equal to, you could do this.get component, and then rigid body 2D. The this keyword is never inherently necessary, but it can help with clarity. So we're going to go ahead and save all these scripts. If you do if you see the little asterisk up there, it means it's not saved. If you do Control-Shift-S, it saves all. Alternatively, file, save all. Or if you just want to save the current script you have open, just Control-S or just save. If we jump back into Unity, it'll do this little reloading domain. This is what the namespaces helps with. It speeds that up. So now you can see we have these two scripts, and you can see the code in them right here. We're going to go ahead and right-click, and we're going to create a player stats object. So this is what that create asset menu did. If we do create, now you see this little player and then player stats. So we're going to do that. We're going to name it player stats. And then here I can change the values. I'm going to set both of them to 5. I'm then going to click on our player game object. Add two different things. I'm going to add a rigid body 2D. I'm going to change it to kinematic. Kinematic just means the only physics that will be applied to it are the forces that it applies itself. We're going to change collision detection to continuous. Our player is going to be moving a lot, so we want to constantly be checking for collision. And then constraints, we're going to freeze rotation. We don't want our object to be able to rotate. Okay, go ahead and close that. Now we also want to add our player controller script, and then we want to drag our player stats into that like this. Alternatively, if you click the little circle right here, it will pull up every player stats object you have. We only have one, and then you can choose which one you want. So we want the player stats. We'll never create another one of these. Okay, you can go ahead and save. Make sure you're saving constantly. If you do something, you see a little asterisk, it means it's not saved. So make sure you save every time you come back. Okay, now let's go ahead and get some movement hooked up to our player controller. So we're going to go ahead and create two functions. One is called update. This is ran whenever you see this Unity message. That means it is run by Unity automatically. So we're not going to call it ourselves, but we're going to create one that is going to be called, we're going to call this handle movement. This is going to be responsible for handling a movement. We're going to head and call this in update. Oops. Okay. Now, what do we want to do in handle movement? We want to get movement from the input manager. So what we'll do is we'll create two different variables to hold which direction So we'll do an x value, and we'll set that equal to input.get axis. And then the name of the axis is horizontal. I'll show you where to find these in just a second. And then we want to get our vertical axis and store that in a floating point value called y. Then what we're going to go ahead is we're going to do rb.velocity is equal to new vector 3, xy0. Now we want to normalize it because of a little thing Pythagoras figured out, which is if you go diagonally in a vector, the line's going to be a little longer. And what we're going to do is we're also going to multiply this by our player stats object dot speed. We need our underscore player stats and dot speed. Okay. Now we'll go ahead and click save. Jump back into Unity. Okay, and if we go ahead, click play, we should now be able to use the arrow keys and W, A, S, and D to move in the eight cardinal and ordinal directions. If we go ahead and stop, you might have noticed that there was a lot of, or it seemed like there was a lot of lag when you were doing this yourself. We can fix that if we come to here to edit, project settings. I'm going to dock this right up here. And then input manager, you click the little drop down to view all the axes. You can see this is your, you have two different vertical and horizontal axes. It'll get either of these. I'm going to stick with just these top two. So horizontal, what I'm going to do is I'm going to set both the gravity and sensitivity from 3 up to 1,000. This is the speed at which it increases and decreases. So the lower the number, the smoother it is, or more gradual it is. So I'm going to set these to 1,000, so it'll be pretty much instant. So now if I come, I can just tap in little directions and move exactly that amount. Alright, now we're going to go ahead and get ourselves a little tile map set up. So I'm going to go into our tile maps folder. I'm going to drag in the tile map I provided. Go ahead and feel free to make your own. This was created for a 16 by 16. So we're going to change pixels per unit to 16. This one is going to have a collider, so we're going to keep generate physics on. We're going to do from normal quality, or for compression from normal quality to none, because this is relatively small. You see there 112 by 48 pixels. And then I'm going to come here and click apply. We're then going to come here, sprite editor. I'm going to dock this right here. We're actually going to go ahead and, oops. Sorry, we also want to change filter mode to point no filter. Okay. Now it should be looking a lot clearer over here. So what I'm going to go ahead and do is slice this. So we actually need to change this from single to multiple. Make sure you click apply again. And then slice, we're going to do by cell size. Size of each of these cells is 16. This is just going to be Unity slicing up our tile map into a bunch of smaller stuff. So if we click apply up here on the sprite editor now, you can see we have all of these different tiles down here. Okay, now we're going to go ahead, we're going to come here to create. We're going to come to, find this 2D tiles rule tile. We're just going to call this top tile for now. Default sprite, go ahead and drag in this one with all borders. I believe it is, they don't have, yeah, it's number 11. So we can go ahead and drag that into default sprite. Now go ahead, number of tiling rules. We have 16 of these. So go ahead, put this number to 16. Now what we're going to do is we're going to drag in each tile one by one into this little spot right here. Just in going in order, like so. Lost track. 1, 2, 3. All right. Now what we're going to do is we're going to define the rules for these tiles, which is why it's called a rule tile. So this little thing in the middle, this is where this tile is existing, and then we need to define the rules to get this set up. So this top one is our top left corner. If you want to view the whole tile map, you can open up and you can see it like this. So it's split like this, so we go along from top left to right, etc. So this one needs to exist when there is something to the down of it and to the right of it, and not above it or to the left of it. This one needs to exist when there's something below it, to the left of it, and to the right of it, but not above it. This one, needs to be the inverse of that one. And I'm left clicking to do the green, right clicking to do the X. This next one should only exist when there's one below it, but there's not anything next to it or above it. This one should be when there's the right to it, only to the right of it. This one should be just to the left and right. This one should just be just to the right and next to it. So a different version of this one. This next one should exist when there's something on all sides. This next one should exist when, let's see, tile 9, let's make sure we're on the right one. That's tile 8. Okay, so I got mixed up somewhere. Double check. Oh yeah, this one should not have one right there. There we go. I'm just going to fill out these rules. Feel free to follow along. And if you want to create your own tile map, feel free to do so. This one's pretty simple, so the more elaborate your tile map is, the more rules you will need to set up for it. Okay. Let's see if I did this right. So now what we're going to do is we're going to come up here, we're going to right click, we're going to come here to 2D object tile map, and then rectangular. Just call this top. Now we also, then we want to come here to window, 2D tile palette. I'm going to dock this right next to our sprite editor. And we need to create a new palette. So I'm going to call this our top palette. I'll click create. It's going to ask us where to create it. I want to create it in our tile maps. So I'll set select folder, and here it is. All right, now if I double click on this, I can drag in our rule tile, and now I should be able to start drawing with it. And the tiles should fill themselves in correctly, and it looks like they are. With a couple errors. I will be right back and let you know when I find out what rules I got wrong. Alright, I went ahead and made the corrections. It's just up in a couple of these, so go ahead, pause it now, make sure you have all of the settings right. I don't think it's too difficult to figure out how the system works. So now what we can do is the hotkeys is if you press D, that switches you to erase mode. If you press G, that is fill mode. So I'm going to go ahead and erase my little doodles here. Now I'm going to go ahead and you press and draw in some tiles around the edges. This white rectangle you're seeing is the bounds of the camera. So I want to go ahead and make sure it goes out of the camera as well. Doesn't need to look super pretty. Okay. I'm going to go ahead and add in some corners right here. Also going to add in a couple islands to check with our collision. Okay. I'm going to go ahead and click save. Now we need to do a couple things. We need to add a collider to our tile map. So we're going to do a couple things. We're going to add in a tile map collider. Another thing we need to do is we need to set mode from chunk to individual. If we keep it on chunk, it'll put one collider over the bounds of the entire thing. We want each tile to have its own collider. So we're going to go ahead and do that. We're also going to go ahead and add in use by composite. This will make it more performant, but we need to add in a composite collider, which also adds in a rigid body 2D. We don't want our tile map to have physics, so we need to switch its mode to static. And that should be good. If you want to define the if you have working with a different tile map and you want to define different colliders for each tile, it's just as simple as coming up here and you do custom physics shape, and then this allows you to draw different physics shapes. I'm just going to keep the default we had generate physics shape on, so the physics shape should be just the shape of the entire thing. We can go ahead and test that by coming to our player. Now our player has physics, but it doesn't have a collider, so I'm actually going to give it a circle collider. This is so you can see here the circle that is making up. If you toggle this on and off, you can see the little circle. You can see it better if we go ahead and set our sprite to something a little darker. There you go. This means just if it gets stuck on a corner, it'll be able to move to the side a little bit and won't get caught. Okay, so let's go ahead and press play. You see I can still move. Looks like I can still leave. Let me go ahead and see what settings I have on this. I think we want dynamic, and then we want to turn gravity off. There we go. So now if we go ahead and try to run into any of the tiles, it's going to stop us. And if I'm just down a little bit and I go to the left, I'm not going to get completely stopped, so I'll still be able to run around stuff. Okay, now you can feel free to customize your little tile map however you want. We'll go ahead and get some walls and shadows in and a floor in just a little bit. Alright, all I've done here is I've dragged in the wall, shadow, and floor tiles. All of these should have links in the comments to where you can grab them. I'm going to go ahead and set all of them to 16 pixels per unit. However, I'm also going to turn the physics shape off because these should not have physics. Filter mode to point, compression to none, click apply. On the wall and floor tiles, I also want to set it to multiple. Click apply. Then similar thing in wall tiles, we're going to come here to slice, automatic, cell size. Again, 16 by 16. We'll hit slice and then apply. Similar thing with the floor tile, slice, apply. Shadow tile we can leave as is. Now we're going to create two more tile maps, or two more rule tiles. Sorry, I'm going to come up here to create 2D tiles rule tile. I'm going to call this wall tiles. Okay. I'm going to expand our wall tiles. I'm going to set its default sprite there. Number of ruling tiles 3. Then what we're going to do is we're going to drag in each of these. Sorry, 4. Now this one should only be when it has something to the right, nothing to the left. This one should be when it has something on either side. This one should be only when it has something to the left, nothing on the right. This one should have nothing anywhere. The default just means if you can't find anything that fits one of these rules, it'll use this one instead. So now we'll go ahead, we're going to come up here to our top, or to our grid. I'm going to right click on it, 2D object, tile map, rectangular. I'm going to call this walls. I'm going to come here to tile map. I'm going to drag in our wall tile. I can actually rename this to just tile maps, or rather rule tiles. Now, when I'm on my walls, I should be able to draw it. Now you'll see it's kind of overlapping, it's not lining up. So what I'm going to do is I'm going to draw it just down below, like this. Okay. Now we'll click on the game object, and we're going to offset. We're just going to set its Y position to 0.5. And now you can see it lines up pretty much perfectly. Okay. So now if I click to game view, you can see this is what it looks like. Now we want our shadow tile. So what I'm going to go ahead is I'm going to click on our rule tiles, come here to tile palette. I'm just going to drag our shadow tile right in. It's going to prompt us to create a new asset tile. So I'll say yes. We want to call it shadow tile. So here it is. Now I want to do something similar where I right click 2D object, tile map, rectangular. I'm going to call this shadow. And you can see we're able to draw it just like this. However, we want this to be rendered below our walls. So what we're going to do is we're going to come here to order and layer, and I'm going to set this to -10. Now you can see it is below. If I click game, you can see that's what it looks like. It looks like it might need to go up a little bit, so let's try 0.25, and there it's not so big. Okay. Now for our floor tiles, I'm going to do something similar. Grid, 2D object, tile map, rectangular. We call this floor. Now I'm going to create a new rule tile again. So create 2D tiles rule tile. I'm going to call this floor tile. Can just drag these in. We want 2. Sorry, we just want 1. But what we want is, instead of output, we want random. Size 2. We're going to drag in each of these here. And then you can shuffle noise. And then there's also size. So this uses per line noise. So let's try a size of 5. Oops, sorry. We want our size of 2 to be kept. Okay, now this is the noise. So if you want to see an action, what we want to do is we want to come here to floor, tile palette. I'll drag our floor tile in. I can go ahead and draw it in like this. It's using the bucket tool. Now I want to go ahead and move it down. So I'm going to move this under our shadow, which is at -10. So I'm going to move this to -15. Now you'll see our shadow is really dark. So I'm going to come here to our opacity and lower it to about 0.7. There you are. Now I'm not a super big fan of this noise as it stands currently. I think low noise values leads to smoother patterns. I'm also going to make our tiles a little smaller, so I'm going to come up here to scale. I'm going to do 0.5 on either end. So that's going to be a half tile. You can come here again with G bucket tool to expand it out. You can play with the noise a little bit more. Oh yeah, I kind of like that. Okay, so we're going to leave it like this. And I just realized I forgot to draw in some of my shadows. I'm going to go ahead and fix that. There we go. Now it's starting to come alive. Now you'll notice if we go ahead and press play, we have this annoying little line. We got a line up here and a line down there, line right here, and it looks kind of ugly. So let's go ahead and fix that. So what we need to do is we need to create what's called a sprite atlas. So sprite atlas, I'm just going to call these tiles. You want to come in here, no compression, objects for packing. I'm just going to drag in our floor tiles. And then hit pack, and you can see now the lines have gone away. This just allows Unity to more efficiently and more effectively use our tiles. You can do that with the other tiles as well, but I wasn't getting the lines, so I'm not going to bother. Another thing you'll notice is that I go under the wall, which I don't really want to do. So what I can do is I can change our walls order and layer to -5. I can go ahead, check this again. Now I'm above the wall. Alright, that's pretty much all there is for tile maps for at least this tutorial. Alright, let's go ahead and improve the looks of our player. So what I'm going to do is I'm going to drag in a sprite file into my player folder here. Again, you should be able to find this in the provided assets in the description of the video. So I'm going to go ahead and just like our tile map set, its pixels per unit to 16. Don't want a physics shape. I'm going to keep the pivot alignment on the bottom, no filter, and no compression. Go ahead, click apply. And because this is an sprite file, we can go ahead and open it up and view all of the different frames involved with it. And what it actually does is it creates the animations in the animation controller. So we don't need to do anything else in terms of imports. We want to go ahead, we want to open up our player, click on sprite, and we can go ahead and just drag the default sprite into its sprite renderer. And we want to go ahead and set the color to white so it doesn't multiply the color by anything. Now I'm going to come back over here and add an animator to our player controller. Now you can click this little circle here, it'll open up all your animators, and we want our little wizard. So we can go ahead and view this. If you want, you can come here to Window, Animation, and then Animation. And I'm going to dock it right here with our console. And you can see this is read only because all of the animation is done in sprite. So you can see there's our idle, and here is our run. Okay. I'm also going to go ahead and I'm going to change our circle collider so it better lines up with our player. So I'm going to offset it a little bit, and you know what, I'm actually going to replace it with a capsule collider, which is a pill-shaped collider. So we can go ahead, we can view it right there, and I want to offset it a little bit so it is now up, and that looks good. Okay. So now if we go ahead and we click play, you can see it's always idle. So we need to do two things different. We need to go ahead and have it so the player is facing the direction they are moving, as well as have it change the animation between idle and run depending on whether or not the player's moving. So the only thing we'll need that is we'll need the name of these animations. They're lowercase idle, lowercase run. So we'll go ahead and we will open up our player controller. Okay. Similar to the way we grab reference to a rigid body, we want to go ahead and grab reference to our sprite renderer. So I will go ahead and just call this SR. Now if you recall, our player script is attached to this parent object, whereas the sprite renderer is attached to this child object. So rather than doing SR is equal to this.getComponent sprite renderer, we're going to do getComponent in children. And this will search, what this does is it searches all of its children from top to bottom and then searches for the first instance of a sprite renderer. So this will work 10 times out of 10 in the case where we only have one child and one sprite renderer. You do run into issues when you have multiple. Okay, Now what we want to do is we want to go ahead and we want to grab the input vector that the player is inputting. So we'll do sr.flipx is equal to, now true, it means it'll be flipped. Now if we go ahead and we come back and we look at our sprite, we want the sprite to be flipped when the player is moving left, so when they have negative velocity. So we want to do sprite render.flipx is equal to x is less than 0. Okay. Now, if we go ahead, we save, we come back into Unity. You should see nothing looks any different. However, if we go ahead and rerun this, you can see now when we move left, we get flipped. But you can see when I stop moving, I flip back. So let's go ahead and let's fix that. That'll be a pretty simple fix. All we want to do is we want to do flip x is equal to, we want to keep that, but we want to add another conditional. We wanted to do if x is not equal to 0f. So we only want to change the flip if the player is moving. So we go ahead, save that, jump back in, go ahead, run it again. You can see now when we stop moving left, we stay flipped. Okay, so that's how we flip the sprite render. Now let's go ahead and let's set our animation. So now what we want to do is we want to do if, and rather than using input, I'm actually going to use I will use the actual player's velocity. So what I'm going to do is I'm going to create a new vector2. So we're going to do vector2, and we're going to do movement vector. And we're going to do new vector2 and x and y. Rather than doing this right here, we can just replace this new with our movement vector. Okay. Next step we want to do is we want to say if movement vector dot magnitude is greater than 0f, so if we are moving in any direction, then we want to change our animator, which means we need access to the animator. So we're going to go ahead, we're going to add in another variable. This is going to be of type animator. I'm just going to call this animator. We're going to do something similar. If we look at our player, the animator again is not in here, it's in the sprite. So we want to do another get component in children. So I'll go ahead, copy this. We're setting the animator, and we're doing get component of type animator. Okay. So now what we can do is we can do if we are moving in any direction, in any capacity, we want to go ahead and we want to set our animator dot play, and here's where it's important to pass in the same name that you see in the asset right here. Now, if they are not moving, we want to do animator dot play idle. Go ahead, save that, and jump back into Unity. And we should see that the player is now running and idling when they are not moving. Okay, the one last step we'll add here, we're done with our animating, is let's go ahead and give our player a shadow, because I think he looks kind of empty without it. So we're going to come here, we're going to right click on our player, we're going to do 2D object, sprites, circle. We're going to come here, we're going to move its order and layer down to -1, so that way it is below this guy. And we're going to go ahead and we're going to squash its y to about 0.5. Okay, now what I'm going to do is I'm going to set it to be kind of a darker color, and I'm going to move its opacity down, excuse me, to about 0.7. Okay, now because, like I mentioned earlier, we now have 2 sprite renders in our children. However, the way Unity searches for get component in children is always goes from top to bottom, so this shouldn't cause any issues with our sprite being flipped properly, and that is the case. Okay. So now we have a little wizard guy that can't collide into any of the walls, or can't pass through any of the walls. He has collision, has a shadow, animates, and flips properly.